The market is open, prices moves like waves, up and down, and you have only got one shot. Buy low, sell high, and get the most of it. Hi, I am Ivasiuta Alexey, and today you are facing a new algorithmic quest. Best time to buy and sell stock.
You are given an array prices, where prices I is the price of a stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and a different day in the future to sell the stock. Return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, you return zero.
This challenge sounds simple, just buy low and sell high. But when the pressure is on, even something this clear can trip you up. So let's begin with the most straightforward approach and see where it takes us. Let's go through an example step by step. We have an array of numbers 7, 1, 5, 3, 6, and 4, which corresponds to the following chart. First, let's consider buying on day 1 where the price is 7. If we buy on this day, we won't make any profit. All the prices in the following days are lower. Next, if we buy on day 2, when the price is 1, the best option is to sell on day 5, where the price is 6. This gives us a profit of 6 minus 1 equals 5. If we buy on day 3, where the price is 5, the best option is still to sell on day 5. The profit in this case would be 6 minus 5 equals 1. If we buy on day 4, where the price is 3, again the best selling option is day 5. That gives us a profit of 6 minus 3 equals 3. Now, if we buy on day 5 or day 6, we don't have any days left to sell the stock afterward, so we can't make any profit. As you can see, the best overall choice is to buy on day 2 at price 1 and sell on day 5 at price 6. This gives us the maximum possible profit of 5. So basically we go through all possible pairs of days and try to find the maximum profit we can earn. Let's turn this idea into the code. First, we create a variable called maxProfit and set it to 0. This will keep track of the highest profit we have seen so far. Next, we use two nested loops. The outer loop selects the day to buy the stock, that's I. The inner loop picks a day to sell the stock. Any day after the buy day, that's J. For each pair of days, we calculate the profit by subtracting the buy price from the sell price. If this profit is greater than the current value maxProfit, we update it. Once we have checked all possible pairs, we return the highest profit we have found. The code works and it gives us the correct result. But how well does it perform, especially when the input gets bigger? Let's take a quick look at the time and space complexity. The brute force solution has two nested loops, so the time complexity is big O of n squared. That means the number of operations grows quickly as the input size increases. And that's a lot, especially in coding challenges with strict time limits. As for space complexity, we are not using any additional data structures. We are just storing one number maxProfit, so the space complexity is big O of 1. It is a good starting point, but we definitely need to optimize it. Is it possible to solve this in a linear time, going through the array just once? Let's find a smarter way and go back to our chart for a second. If we look more closely at the price trend, we will notice that the ideal buy and sell moments often line up with the lowest and highest points. With one important condition: the lowest point must always come before the highest point. To find the answer in a single pass, we need to keep track of two things as we go through the array: the lowest price we have seen so far, and the maximum profit we could earn if we bought at that price and sold today. So let's walk through a few examples. We define two variables: maxProfit initialized to 0 and minPrice initialized to a very large number, something higher than any price on the chart, like 99. We begin with the price 7. Since it's very first number we see, we set it as our initial mean price. Next comes a price of 1. That's clearly lower than what we had, so we update mean price to 1. It is a better buying opportunity, but we don't calculate profit yet. We haven't seen any future prices to sell at. Now that is higher than our current mean price, which means it's worth checking the profit. We calculate it and 5 minus 1 gives us 4. Since 4 is higher than our current max profit of 0, we update it. The next price is 3. It is still above the minimum of 1. So again, we check the potential profit. 3 minus 1 equals 2. That's lower than what we have already seen, so we do nothing and move on. Now we get to a price of 6. Once again, it's higher than mean price, so we do the usual. 6 minus 1 equals 5. That's better than our current best profit of 4, so we update it. Finally, we arrive at the last price 4. It's higher than 1, but the potential profit 4 minus 1 is only 3, which isn't enough to beat what we have got. So no changes here. And that's it. We have gone through the entire array, checking every price along the way, and the maximum profit we could make was 5. And now let's turn this logic into working code. We start by creating a variable minPrice and we set it to a really large number max value. As we go through the array, we'll update this value whenever we find a smaller price. Then we create another variable maxProfit and we set it to 0. This will keep track of the best profit we have found so far. Now we start a loop that goes through each day in the prices array. Inside the loop, the first thing we do is update minPrice by taking the smaller value between the current price and the existing main price. If the current price is not lower than mean price, that means it is potential sell day. That's why we update max profit to the bigger of itself, or price minus mean price. We repeat this process for every price in the array. After the loop ends, we return the max profit from the function. As you might have already guessed, the time complexity of this solution is big O of n, because we go through the array only once. And since we only use two simple variables, the space complexity is big O of 1. And that's it. We have solved the best time to buy and sell stock problem. We started with a brute force approach and optimized it using a greedy one-pass strategy. If you found this helpful, feel free to like the video and subscribe. There are more quests ahead and more problems to solve.
You watch the prices and waited. You do the profit not when it was perfect, but when it was enough. That is how value is gathered. Return when you are ready to collect more.